Hi, my name's Leland Richardson, and the title of my talk is Cross-Language React. When I signed up to do this talk, I only had a rough idea of what this talk was really going to be about. A couple of months ago, I started playing around with a React-like library that I was wondering what it could look like in other languages other than JavaScript. And so today I'm going to talk a little bit about why I think that that's a compelling idea and really an underexplored topic. So before we start, as Medan mentioned, I'd like to clarify a couple things about me. Up until recently, I was an engineer at Airbnb. And at Airbnb, I worked on a lot of different things, but those of you here probably know me for my work on React Native. And recently, I've left Airbnb to go to Google to work on the Android platform. And so I want to emphasize that this talk covers a body of work that I did on my own and should not be taken to imply things that either my past or present employer is actively investigating. Also, some of the code I'm going to go through today is on GitHub. And it's there sort of for academic purposes. And I don't really recommend trying this in a production app. And I'm not planning on maintaining this code or anything like that. So we're all here because of this library called React. It's a library for building user interfaces. And it was really introduced to the world as a JavaScript library. And I assume for pretty much everyone here, when you think of React, you probably think of JavaScript. And at first, the platform that this library targeted was the web. And over time, some folks realized that React is actually a really good paradigm to decouple the platform implementation from your application's implementation. And so then React Native was born. And React Native allowed for JavaScript developers to use the React paradigm to build iOS and Android apps. However, for native engineers who have been building iOS and Android apps, this was not only using a new language, but it was using an entirely new view paradigm, neither of which they had really been used to. And so what I kind of wanted to explore was what would it look like to take the paradigm of React and really bring it as a first-class citizen to these languages and try to kind of decouple it from JavaScript altogether. So I called this library Recoil, and I tell you that only because I might mention that as a name during this talk. And so it's not really important for the focus of this talk, but it was a kind of an implementation that I worked on that took React and moved it into Kotlin and Swift. And so it's worth asking, what does the public API of such a library look like? And React's public API service area is actually quite small. If you think about it, what we really care about is how do we write components and what's their observable behavior. And so if we start off with JavaScript, a lot of you probably interact with React something like this. We write ES6 classes, we have a render function, and we use this XML-like syntax called JSX. And I'm going to add in a little bit. Some of you may use something like TypeScript or Flow to type your React components. And that would look something like this. And so we're still just in JavaScript here. And so that XML-like syntax, JSX, I'm going to desugar it a little bit into what kind of is actually happening under the hood. And by convention, I'm going to have the JSX pragma be a function called h. JSX elements are really just a function call. And so here we are with JavaScript and Flow in this case. And really mapping that onto a language like Swift or Kotlin is really a lot less of a shift than you might think. And so you can work with languages like this that have first-class type systems, and we can have the same sort of interaction with the UI as we have had before. So this example is in Swift. We have an H function that we pass the reference of a class to, and we're able to have children inside of a Lambda body after that. And Kotlin looks also strikingly similar. And so what I'm really trying to sell you on is that maybe this isn't as much of a shift as you might think. But one important thing to note here is that in both of these examples, in Swift and Kotlin, there's actually nothing on the screen here that is a platform API. Everything that we're looking at is just vanilla Kotlin or vanilla Swift. There's no sort of UI kit or Android View library sort of leaking out. And so this is really just like, it's a pure concept and idea. But you might be wondering at this point, like, why? I mean, we have React Native here. We can do all of this with JavaScript. So what I really want to talk to you about is how React as a paradigm is actually just like a valuable concept, and bring some things to these platforms that they're actually sort of currently lacking. And so I want to talk about why React as a paradigm is compelling to me. So the first point I want to talk about is how React is declarative. iOS and Android's view frameworks are pretty imperative APIs. And people throw this word around a lot, declarative versus imperative. And so I want to kind of try and explain exactly what I mean by that by way of an example. So let's consider an example of a small UI where we have an icon that we're rendering in like a mail or a chat application. And so in this case, you can think of our application state as the number of unread messages that we have. And so for 0 unread messages, we're going to render an empty envelope icon. For more than 0 unread messages, we're going to render an envelope with a badge with some number kind of indicating that number. And then we're going to be a little bit fun. Once we hit 99 or above, we're going to render like a flame icon and just say 99 plus, because who cares after that? So if you wanted to like build this API in an imperative view framework, you might have to write some logic that looks like this. If we have the new count for the number of unread messages, we have to go through and determine whether or not we need to add or remove a badge or remove the envelope or et cetera. And the key kind of thing to take away here is that in this example, I not only care about what the new count is, but I care about what the previous count was. And I have to find out how to reconcile those two states. And so I really have to transition the two. And if I'm writing a UI in a declarative way, it tends to simplify. And the reason here is that in this declarative example, I no longer care about what my current state is. I only care about, given this new state, what should it look like? And so that's a powerful thing. What's happening is that the underlying view framework is doing all of that hard logic for you. And all you're doing is passing this declaration about what you want your view to look like at that point in time. So the next thing I want to talk about is encapsulation. The React paradigm, it has very well-defined ownership, and it enforces it rather well. The public API of a React component is really just its props. The props that you accept is the only way that other consumers of your component can really interact with you. And importantly, you're not, as the component itself, allowed to change the props that are passed to you. They're immutable to you. But if you do need to have state, you can have what React calls state, and that you manage. And importantly, it's only you that manages it. So it's localized to your component. And anytime you find that state is in has a value that you don't expect, you can be sure that it was changed by you in that component file. And that's a pretty strong guarantee to have. And if you think about it, this is why we have controlled components. If an input was able to manage its own state, it would be the only one managing its state, and inputs would never, we would never know what their value was. And so inputs in React naturally become controlled components. And so a side effect of this is that state sort of naturally flows down the tree. And if you want state changes to go up the tree, you use that, you do that with callbacks. And so finally, I want to talk about React's composition model. And really, composition is kind of a broad term. And a lot of times, when we have object-oriented languages, the sort of composition model that is used is inheritance. And actually, React really strongly pushes you away from that. And so React's composition model is closer to what I would call functional composition. And so I'm going to kind of go through an example of where inheritance actually breaks down. Because a lot of you, like me, are maybe used to thinking of things in terms of inheritance. So let's say we're using an object-oriented view framework. And so we have an input, and naturally we subclass view because it's a view on the screen. And then later we say, okay, well, I want a validated input. I want to have an input that has some validation logic. So I'm going to subclass input. And then you kind of keep going. You say, okay, well, now I want a date input, and that naturally I want to validate that date, so it should subclass validated input. And then finally you might say, okay, well, now I'm going to have a date range input, and it'll have two dates. And now I want to reuse that date validation logic that I had in my date input. But you're kind of lost now at this point, because you actually have two dates that you need to validate, and it is a single view on the screen. And so what is the natural way to compose these other things with inheritance? And there really isn't a model for that. So inheritance kind of breaks down at this point. And if you compare that to React's compositional model, we can consider us having an input component and then a validated input component that then renders the input with extra props passed in to do validation. And a date input then renders the validated input. And so then when we get to the date range input, it's actually quite natural what we need to do. We can reuse the date input just like we expected we should be able to. And it's not a linear composition model, so I'm able to compose multiple things at the same time. And really, the composition is just a projection that the render function is doing onto these other components. And so it works quite nice. And another example of this is, I guess, what you could call containment or decoration. So let's consider a view that we'll call Fancy Box. And Fancy Box is really, it's a generic thing, but we want to have some views that just look fancy, and we kind of decorate the sides of them. And so we create our Fancy Box class, and then let's say we have some other view classes like blog post and edit form. And then all of a sudden we decide, well, we want a fancy blog post and a fancy edit form. And it's really unclear what we need to do at that point, because now we have two things that we kind of want to subclass, but there's no sort of linear inheritance backwards that we can get that. And so we're kind of stuck here again. And kind of as you'd expect, React handles this quite well, where with React, we can just create a new component that then composes the other two. And there's kind of a natural sort of wrapping that you can do with components like Fancy Box using React's children. And so this is a really powerful way to build up from small primitives into a very large, shared and scalable code base that has a lot of reused but isolated logic where the public APIs are quite clear. So I hope at this point I've maybe been able to convince you that there's actually a lot of really good ideas in React that are are sort of ideas that don't have anything to do with JavaScript itself and could apply very well to other platforms and other languages. And so now I'm going to kind of dive into a little bit like how React works and how we might go about building such a thing. And when I think about React, I tend to think in terms of three phases. The render phase, the reconciliation phase, and the commit phase. And so if we're making an update to our UI, we would start off and we would call the render function of the component that's doing the update. And render returns this sort of declaration, as we saw earlier, of what our component should look like. And we call those elements. And we essentially take that result and we pass it into reconcile. And reconcile is going to look at the previous version that component returned. That's sort of like the version on screen, if you will. And it's going to start doing some comparisons. And when it finds in that hierarchy that you passed it more components rather than like leaf nodes, what it's going to do is it's going to then recursively sort of go back to render and call render on that component. And then it's going to continue kind of down this path, down render and reconcile. And so the bit that I left out is that reconcile actually does more than just make a recursive call. It actually has a kind of a record keeping that it does, where when it runs across sort of what I'll call leaf nodes at this point, it'll look and see what has changed. And this is kind of like what that imperative render function was doing earlier in that envelope example. But it's gonna record a list of operations that it would need to do in order to get the UI into the new state. And so those operations haven't been executed yet, but they've sort of been recorded as something that's needed to happen. And so once all of those build up and the recursive call terminates, we have this big list of operations, and then we start going through what I call the commit phase. And this is where we essentially flush that queue of operations. And that is where the actual sort of pixels on your screen change. And so this is an interesting model. And there's a lot of different ways that you can sort of sequence these operations. And so what I want to talk about, and kind of starting with that, I like this quote by Jeff Bezos. It says, "Constraints drive innovation. One of the only ways to get out of a tight box is to invent your way out." And I think this is a really important principle. When we think about the innovation that React had, let's first think about what the constraint was. The constraint was that JavaScript is single-threaded, and as we demand more and more out of our JavaScript applications, that becomes a more and more difficult ceiling to deal with. And so React's big innovation, really, when it comes down to it, was solving this sort of scheduling problem. And another way to say that is that they built Fiber. Fiber introduced kind of a new way to go through this render, reconcile, commit sort of dance. And what it allowed JavaScript to do is sort of pause in the middle of this recursive call and kind of maybe hold it over here while it goes and does some more important things and then resume later on. And that's a really challenging thing to do in a single-threaded application. But it's difficult to do in a multi-threaded application as well. And I think that in iOS and Android, which are both sort of multi-threaded environments, what happens is that when we run into ceilings like this, people kind of quickly resort to threads. But they don't necessarily rethink their whole architecture like we did in sort of the JavaScript community. And so I think what we've done is React and the Fiber architecture, I think now actually presents a really compelling architecture to bring into a multi-threaded world, where we've actually done a lot of the foundational legwork of making our view framework really amenable to this kind of scheduling. And then in a multi-threaded environment, we can do a little bit more of that scheduling in more powerful ways. So going back to these three phases, I want to kind of cover how these phases are used currently. In React DOM, we have all three of these phases run on one single thread. And what Fiber did is it kind of changed the fact that this is now an asynchronous operation potentially. And so we can pause and do some other things in between, but it's still on a single thread. React Native actually has a different model. And so in React Native, render and reconciliation happen in the JavaScript world. However, commit needs to happen natively. This is what people mean when they say that React Native is like really native. What happens is we serialize those view operations to the main UI thread and actually execute them against real native views. And so when I wrote Recoil, I thought we can do it kind of the same way. We can have render and reconciliation kind of happen on one thread, and then the commit thread needs to, as always, happen on the main thread. But we actually now have a little bit more power. So instead of having it run on a single JavaScript thread, we can actually play around with where this render and reconciliation happens, because we can run it on any thread. And so to show a couple of these examples, I'm going to show you some graphs here. And these colors are sort of meaningful, but they're just meant as visual cues. So I'm breaking up these three phases. And then I'm adding also layout and paint, which happen to be relevant in these situations. Layout is kind of what you would think, where the views get laid out, which sometimes can be separate. And then paint is actually like the GPU rendering the pixels on the screen. And so React Web, as we'd imagine, is sequential. It's in a single thread, and it all kind of happens linearly. And then React Native actually has a pretty interesting threading model. What happens, as I mentioned, is render and reconcile happen on the JavaScript thread. And then there is actually a little bit of work that needs to be done for the commit phase, just to serialize and turn those JavaScript-based operations into native ones. But React Native actually batches these commit phases while it goes down this recursive call all the way down render. And it hands it off to a separate layout thread, which actually isn't the main thread. And then layout is done on those views, and then eventually passed up to the main thread. And so this is a pretty compelling model. And so for Recoil, we can do something pretty similar. And this actually works rather well. But we can go a bit further. So what happens if we take some of those render reconcile operations and move them to an additional thread? We can start to parallelize some of that work. We can start working on a tree and then turn its children, and start parallelizing them in other threads. And this is actually pretty important on mobile devices. Mobile devices are not really getting faster in terms of raw computational power, but they are getting more and more cores. And so different devices could have different threading models here, where we can really kind of make things faster. Now, a really interesting thing that kind of comes out of this, I think, is the splitting up of render and reconcile. And when our reconciliation engine is native, what we can do, the thing that we're reconciling is just a data structure. And it actually doesn't really matter where that data structure comes from. And so we can start having some components run render in JavaScript and other components run render in Swift or Kotlin. And we could choose potentially which components we want to use which language. And this is very much experimental, and I didn't actually get a working concept of this today. But I am quite sure that this is possible and may be pretty compelling from a performance standpoint to have optimal components or components that are kind of optimized and naturally fit in the native model, and then have some other components kind of run in JavaScript. And how that could work, I think, is pretty interesting. So there are some other things that fall out of this. One thing that's pretty interesting to me is this concept of layout-aware components. And some of you may have run into this at some point, where we have this component that needs to render one thing or another, kind of depending on the available space that it has. And there's really no good pattern to do this right now with React, because the very first render call, you don't actually have the backing views of that React component don't exist yet. And so you can't really ask their size. And so the way people tend to do this is something like this, and I'm simplifying it a bit, but basically you just kind of render a thing that fills space. And then in component did mount, you really quickly measure it, and then you run render again. And so this does a lot of sort of unnecessary work, especially if you can imagine like small thing or large thing here could be really expensive. And so really what we want is an API that kind of looks like this, where we can be guaranteed that every render is actually passed the layout metadata from the layout pass itself. And we don't have these hooks on the web. We would have to kind of build layout ourselves if we wanted to do that on the web. But in native, we do, actually. And so I started playing around with this kind of concept where you could have components that actually participated in Yoga's layout algorithm. And as soon as you would run into one of these components, it would kind of pause layout, and then it would run render of this component at that time. And so you can kind of imagine what this API would look like. I have the Swift API here, and the Kotlin API is quite similar. And then it kind of looks something like this. And so because we now have this power to sort of shift where render and reconcile happen, we're able to run layout and kind of pause in the middle and then start rendering and reconciling the subtree as we go along on that thread. So another thing I want to talk about is host components. And this is a term that maybe not all of you are familiar with, so I'm going to try and run real quickly through what this means. So here's a fancy button component, and this is maybe a component that any of you would write, and this is what we call a composite component. And so when you do a JSX element of this component, that really just turns into a thing where the type references that component directly, and it's a React.component subclass. And so for React Web, you can't actually define new host components, but you probably use them all the time. And so in this case, host components are things like div and span, et cetera. And if you look at what the JSX produces, the way this materializes is actually just as a string, where React DOM sort of special cases this thing. And for React DOM, the set of host components that we have was kind of already defined for us, right? It's just HTML. And this is actually the platform that we're targeting. We're just rendering HTML elements. And so we can't really go beyond that. However, the situation is a little bit different for React Native. React Native also has host components, and I'm sure all of you use them. There's they kind of look like composite components on the surface. You have something like Vue, and that actually points to a Vue React.component subclass. But actually, in the release build, this gets converted directly to an RCT Vue string. And that's sort of the host components of React Native. And a lot of them just ship with React Native. But what React Native offered that React DOM didn't is the ability to define new host components. And this is actually a very powerful thing. And so some of you may have seen code like this before, but on iOS, you define host components like this with a view manager. And on Android, you would define a similar view manager, something like this. And these APIs have traditionally been somewhat underutilized, I think. But I went ahead and kind of made similar sort of concepts in Recoil. And what I think is interesting is if we had a React community that was sort of built on top of these languages, where Swift and Kotlin were kind of the actual language of implementation, then you might have a lot more people. It would be a lot more accessible to switch between a composite component and a host component, depending on which one was more advantageous for you, because it's just right there. There's not a lot of this extra ceremony that React Native currently has. And so I'm running over time here, but I'm going to quickly talk about how this gets a little bit more interesting when the host components that I showed you were targeting the sort of platform views. So you have on iOS a UI view that you target, and on Android you have a Android.view. And actually, these are fairly heavyweight objects. There's actually already optimizations in place in React Native that try to collapse view hierarchies so that we don't create as many views as like React kind of lends us to create. And so there's actually this idea to have some host components that don't target the underlying view framework, but actually one step lower. And so on iOS, you could target CA layers directly, and these are much lighter weight and could have a huge performance gain for the views where this would make sense based on their APIs. And similarly on Android, you could target drawables, which are just things that sort of draw to a canvas. So that's about it for me. But what I want to do is kind of wrap this talk up a little bit. And I really want to say that the React paradigm itself, I think, is a really powerful thing. And so it's good for us as a community to think about how we can apply it to other communities. And it really it stands on its own. It doesn't need sort of JavaScript or the web to kind of make it a powerful thing. And also, I really need to shout out that there's already a lot of really good work in this area. A lot of you are probably familiar with Reason, which is bringing React to potentially another language. There's also frameworks like Component Kit and Litho that have a React-inspired API on iOS and Android. And so I think that there's a lot more work to be done here. And it's very much underexplored, and hopefully, maybe someone in this audience can be the one who explores it further. Thank you.